Hello everybody, today we're going to be dealing with trigonometric ratios in our journey in geometry. So what exactly are trigonometric ratios? Well, we have the first three here, which are the sines, the cosines, and the tangents. And so we can find these values using the mnemonic SOHCAHTOA. And what does this mean? So means sine is equal to the opposite over the hypotenuse, and I'm going to go over these terms soon, so just wait for them. The cosine is equal to the adjacent divided by the hypotenuse, and this t here, the tangent, is equal to the opposite divided by the adjacent. Well, what exactly are the opposite, hypotenuse, and adjacent sides of a triangle? After all, I do have three sides labeled here and their values. So let me get you started on that. What does it mean? Well, so in essence, we can say that the hypotenuse, which is probably the easiest one of these, is the longest side. It's usually this side here, because it's the longest. Here's going to be 6. Here is the hypotenuse. Let's call it h, because we have it labeled as h here. Let's start with the sine first, because the sine is typically one that I like the name sine. It's written commonly like sin, but it's pronounced sine. And I haven't talked about this value here. This is called theta. Theta is the angle that we're essentially looking for. We're not looking for this right angle here, we're looking for this angle, theta. We're looking for the sine values of it, the cosines of it, and tangents. There's going to be 3 more trigonometric values that I'm going to talk, or ratios I'm going to talk about in the next video. But this is just a simple part of the geometry, this first 3 values. And the opposite is called the opposite is the side that is the opposite, as the name implies, to theta. And so in this case, it would be 4, right? Because this side, this angle is on the opposite side of 4. And so we can say, let's get a different color here, shall we? What about 4? And now we have our values that we can use to essentially solve this or find the sine of theta. And so our opposite is going to be 4, right? Divided by our hypotenuse, which is 6. And so therefore, when you simplify it, our sine of theta is going to be 2/3, right? And so what about the cosine here? Cosine, I'm going to go a little bit faster this time. We're going to find the adjacent and the hypotenuse. And since I haven't already labeled it, so this is going to be obviously the adjacent. The adjacent is the side adjacent to the, as the name implies, to the theta that is not the hypotenuse. So once you ruled out the hypotenuse, finding the adjacent is super easy because it's the other side that is adjacent to the theta. And so let me also label this as opposite because I forgot to. Opposite. Right? And so our cosine this time is going to be our adjacent, so which is going to be 2 here, over hypotenuse, which is 6 here, and 6 reduced down to 1/3, right? And so our cosine of theta is going to be 1/3, and our tangent, I'm running out of space here, so I'm going to work over here. I'm going to start a different color just to make it a little easier on you guys. Alright, so on our tangent, we're going to have our opposite divided by our adjacent. We've already found it over here in our sine and also in the triangle. I'm going to do it for the triangle for time's sake. So 2 divided by the, what? Oh, that's not, sorry about that. I make silly mistakes sometimes. Opposite, that's going to be our 4. And 2 is our adjacent. And so therefore, our tangent of theta is going to be 2. I hope you enjoyed the video. My dog's barking right now, and so perfect timing. I'll see you next time.